There we go. All right, let me let these people in that are joining here so I don't get off track. Okay. Maybe. There we go. Cool. Okay, so we're still in our geometry module, and today we're looking at triangles. Now, last week we talked about angles and their relationships, so we're going to review that a little bit because triangles and angles go hand in hand, so we're going to be kind of combining that today. Now, I did, if you noticed from last week to today, there were parallelograms and trapezoids in there and rectangles. I did, hang on, I'm going to mute everybody because I've got some background noise going. There we go. I did put a video up about all those so that I didn't skip anything, but it's in your resources. So if you need help on those, finding area and perimeter of rectangles, parallelograms, trapezoids, there are videos in the resources document. And if you need help finding that document, just let me know, but it's in my teacher information folder. And then if you open that folder, you'll see a document that says Get Help, Math 6B, resources, it's all in there. That's the same place that I put all these recordings as well. So you may want to go watch that video if you haven't already, if you need help with any of those. But today we are going to look at the triangles so that I can stay as close to the schedule and pacing guide as possible. So again, we are going to review our angles that we talked about last week. So let's go ahead and do that. So if we look up here on my screen that I've shared, yeah, you guys are already ahead of me. Good job. This first angle right here that I put in, we've already got several saying that it's acute. Okay, this is an acute angle. That is correct. How do we, oh, I don't want ink to shape on. Hang on. How do we know that this is an acute angle? What tells us that it's acute? Exactly. This angle measures less than 90 degrees. Okay, we can tell that because we know that a 90-degree angle is like straight up and down, right? So less than 90 degrees, so it is an acute angle. All right, what about the next one? Yeah, yep, obtuse. And how do we know it's obtuse? Exactly. Okay, it's the opposite of acute. It's more than 90 degrees. So this angle here measures more than 90 degrees. Yeah, that's okay, you got it. All right, and then the last one down here would be what? Yeah, this one would be a right angle, and that little box in the corner tells us that that's a right angle, and it tells us that it measures exactly 90 degrees. So it's no more, no less, it is exactly 90 degrees, and that's a right angle every time. Perfect. Okay, so that leads us into our triangles. Okay, so today we're going to talk about the different types of triangles and how to classify them. So there's different ways to classify triangles. One way is you can classify them by their angles, kind of like what we did here. And the other way is we can classify them by their side lengths. So we'll look at both, but first, since we started with angles, let's go ahead and look at how to classify them by their angles because it kind of just fits together perfectly here. So let's go back to our acute angle up here at the top, and we're going to turn this into a triangle by just adding a side here. So just connecting those two ends of our angle. So now this is a triangle. It has three sides, and it has an acute angle where we had already started with, right? Okay, so this triangle would be called an acute triangle. Okay, an acute triangle is a triangle that has all acute angles, and we can look at these and see that they're all acute because all the angles in this triangle are less than 90 degrees. Okay, yeah, so this would be an acute triangle. It's pretty much that simple. We just kind of created, from the angle that I started with, I just created a triangle, and now I can tell that all three angles inside my triangle are less than 90 degrees. That makes it an acute triangle. Let's do the same thing for this obtuse angle. Let's, instead of an angle, let's connect the ends and make it a triangle. I know my line isn't very straight, but just pretend it is. So yeah, This one is called an obtuse triangle because it has one obtuse angle. Now they can't all three be obtuse like the acute triangle where they were all three acute. They can't all three be obtuse for it to be an obtuse triangle because then it wouldn't connect. Okay, if we had all three acute or obtuse angles, it would just go all different directions and it would never connect to make a triangle. Okay, so in this case, it has one obtuse angle to be an obtuse triangle. Can y'all hear my baby? He's screaming. All right, let me get these other people admitted. There we go. All right, and then a right triangle is again, just like what we've already been doing. We're gonna connect that last, whoops, that wasn't what I wanted. Connect those sides there, or the ends of the angle to make a triangle. Oh gosh, it's moving on me. And a right triangle is just what it looks like. It's a triangle with one right angle. And again, this one's kind of like obtuse. It can only have one right angle. If it had more than one, then it wouldn't connect like a triangle. It'd have more than three sides. Okay, so a right triangle has a right angle. Okay, so that's how we can classify triangles using their angles. So it's going back to pretty much exactly what we did with our angles by themselves. Okay, any questions on that before I move on to the next part? Okay, good deal. All right, so the next thing that I want to point out is something that's true about every single triangle, no matter what kind of triangle it is, however we classify it, every single triangle. So I'm just going to draw one in here. Again, it's not very pretty. Every single triangle, hang on a second. Okay, you're going to have to wait a second, okay? So every single triangle, the angles, yeah, they do always have three sides. That is true. Okay, but when we're talking about the angles in a triangle, all three angles in a triangle always add up to a certain number of degrees. Does anybody know what that number is? Yes, that's exactly right. Yeah, y'all got it. They all add up to 180. I'm going to mute myself for just a second so that I can turn his toy off because it's making a bunch of noise. Okay, sorry about that. Yes, so all the angles always add up to 180 degrees every single time. So they can all be the same thing as long as they add up to 180. They can all be different and add up to 180. If it's a right triangle, we know one angle is going to be 90 degrees and the other two can be something else, but they'll always add up to 180 or else it's not a triangle. Thank you. Okay, so now let's look at how to classify triangles based on their side lengths. So some of you have already done this lesson, so you may already know these, but just in case, we're going to go through all of them. So the first one we're going to look at is an equilateral triangle. And one thing that you want to notice about the word equilateral is that it kind of has the word equal in it. Okay, this is kind of a hint for equilateral triangles. They are triangles that have sides that are all the same length, so all three are the same, and their angles are all going to be the same measure as well. Okay, all three. So this triangle has side lengths. We have two side lengths given, 5 and 5 here, and the other one has a question mark. So it says two of the sides of the triangle are 5 inches. If it's an equilateral triangle, what is the length of the third side? Yeah, y'all are way ahead of me. It is 5 because it's an equilateral triangle. It has to be the same as the others, all the same. It's exactly right. And then if all the angles are equal to each other in an equilateral triangle, and we know that they add up to 180, can anybody tell me what those angle measures might be? Or how we could find it? I haven't seen the correct answer yet. Okay, so no, not yet. Keep trying. Yeah, okay, someone put it in there. It's 60. Okay, so if we know that they all have to add up to 180, and there's 3 angles in every triangle, then we know that we have to have 3 of the same thing. So we could either just subtract, well, really we couldn't really subtract here because we don't know any of them yet. But what we could do is, since we know they're all equal and there's 3 of them, we could divide 180, our total, by the number, by 3. And if we divide that by 3, we get 60. So we know in an equilateral triangle, all the angles would measure 60 degrees. Oops, not 6, 60. Yeah. All right, so that's equilateral. All the sides are the same, all the angles are the same. Then we move to an isosceles triangle. This is kind of small. Let me see if I can zoom in a little bit. It's a little better. Okay, in an isosceles triangle, we have 2 sides that are equal, and that means 2 of the angles will also be equal. Okay, so here's our triangle over here. It says it's an isosceles triangle, and you can see that one side is 8 inches long and the other side is 4 inches. So we need to know the other one, and y'all are already typing it in there. That would be 8. Okay, how do you know it's not 4? If it were 4, we'd still have 2 sides that are same, wouldn't we? So how do you know it was 8 and not 4? Yeah, we could say the base is 4. Yeah, it says, he said, because 1 is long as the 8. Yeah, so we could look at that side and say, okay, it's definitely longer than the one that says 4, but it does look like it's the same as the one that says 8. So we can rule out the 4 since it's longer and say that it would have to be the same as the other side. Yeah, so it would be 8. Good job. Okay, so again, isosceles, 2 sides are the same. All right, here's another question about isosceles. If the angle across from one of the 8-inch sides is 70 degrees, what is the measure of the angle across from the other 8-inch side? So we haven't really talked about this, but let's say that the angle across from this one is 70 degrees. What would this one have to be? Yeah, since they're the same side length, the angles across from each of them would have to be the same as well. So we'd have 2 angles that are the same too. And in this case, if one was 70, they would also be 70. Good job. Okay, last one is called a scalene triangle. Okay, so equilateral triangles, again, have all equal sides. Isosceles have 2 equal sides. Scalene triangles have no equal sides. Okay, which just means that they're all going to be different. So all 3 are different from each other. So this one says, since the sides are all different, the measures of the angles will all be different as well. So they won't have any sides that are the same. They won't have any angles that are the same. Good. Okay, so that's a scalene. So right now we're just going to practice what we learned about classifying them by their side lengths. And we're going to identify these. So let's look at this first one right here. What kind of triangle is this? Yes. This one's isosceles. How do we know it's isosceles? Yeah, 4 and 4, 2 equal sides. Okay, so that tells us it's isosceles. And the other side was 3, so it's not 3 equal sides, it's just 2. Now the next one, yep, already got that one. Someone said scalene, or a few of y'all already said scalene. We know that because what? Yeah, all the sides are different, no equal sides. Okay, what about this one?
Obtuse.
Yeah, this one's equilateral because all the sides are the same. Yep, exactly. 8, 8, and 8. And then the last one, yeah, this one, not necessarily by its sides, but by that angle. This one's a right triangle because it has a right angle. We don't know the side lengths, so we don't know if it's, if we looked at it, we could kind of guess, but since it doesn't have lengths written in there, we can't say yet if it's isosceles, scalene, or equilateral. but we do know it's a right triangle at least. Good. Okay. All right. Do y'all want to do a quizzes practice round? Cool. Okay, let me get it open so I can, that's not what I want. Hang on. I gotta find it and then I'll share that screen again. Okay. This is just gonna be over what we did today. So angles and triangles. Oh, I bet they are cute. All right, my quizzes. Let's see, here it is. Let me pull this over here. All right, I'm gonna put the link in the chat. You should be able to just click on it and it should take you right in. Okay. Here it is. Okay, I just put it in the chat. So look at the message from me. It's a link. Try not to type in the chat right now so people can find it. And click on that.
When clicking on it, it's just staying black. It's like not going to the blue or bringing me to another web.
Okay, there's several that are getting in, so it should be working. Maybe just try to copy and paste it into a web browser and try it that way. See if that works.
We have to use our real name.
Because it is working for several, because we've got a bunch in already.
Okay, hang on, I'm trying that.
That's adorable.
Okay, I'm in.
I still can't get in.
Okay. If you can't get in, go to quizzes.com/join.
Just copy and paste it.
And you can put in the game code, which is 692084. So that's another way. Oh, I didn't mean to send that. I was trying to send it to everybody. And I didn't. Hang on. There, that should go to everyone now. All right, I'm gonna go ahead and start it, but if you're not in, don't worry. Once you get in, you'll be able to still play, okay? But I'm gonna start it for those that are in, just to make sure we have enough time. There's only 10 questions. And remember, this is practice. This is just practice. So don't stress out about it. If you miss one or more than one, it is okay. So far, y'all are looking good. A couple of y'all are on fire. Nice job. Looks like we're pretty good at triangles, guys.